Today we're going to talk about theoretical probability of an event and converting between probabilities and odds. So yesterday we looked at experimental probability, so they actually conducted an experiment, got some results, and then we found probabilities. With theoretical probability, it is what we expect is going to happen. So basically, if I flip a coin 50 times, I expect I'll get 25 heads and 25 tails because those are both equally likely, right? If I had this spinner here, right, then I would expect that every fourth time I spin the spinner, I'm going to land on the same one, right? So, or every fifth time, or I should say every 4 times I spin the spinner, I would expect to get each color once, right? That would be if when they're all equally likely, right? Well, if they're not equally likely, then, chances are greater of one than the other. But theoretically, what do I expect is going to happen is what we're talking about, right? And does it always happen? Nope, not usually. Every once in a while it does, but not very often. But when you're talking about theoretical, we're talking about what we expect. So theoretical probability, number of ways an event can occur, divided by the total number of equally likely outcomes. So when we're talking about theoretical probability, the outcomes have to be equally likely, right? So the same chance for everything. Flipping a coin, those are all 1/2. I get a head, I get a tail. Rolling a number cube, each of the numbers 1 through 6 are all equally likely. If you have a deck of cards, pulling a card out of a deck, those are all equally likely because there's one of each of them. So, an experiment in which all outcomes are equally likely is said to be fair. You can usually assume that experiments involving coins and number cubes are fair. If we're doing a spinner, sometimes the spinner is a little lopsided, and so it might not give you the exact thing you're looking for. Or if you're got a bag of marbles and you're digging in the bag for and pulling out a marble, maybe one of the marbles feels a little different than the other one. So. Okay, so the experiment consists of rolling a number cube. Find the theoretical probability of each outcome. So let's think about the sample space for a moment. All right, so let's write that down. The sample space we have are the numbers 1, 2, 3, 4, 5, and 6. All right, those are all the possible things I can get when I roll a number cube. So, Michael, what's the probability I roll a 5? 1 out of 6. So this is just simply 1/6. The probability of a 5. Letter B, what's the probability that when I roll that number cube, I get an odd number? Scott? 3/6, right? We have a 1, a 3, and a 5 are all the odd numbers, so there's the chance or the probability is 3 out of 6 or 1/2. Okay. So theoretical probability, think about the sample space, think about how often that can happen. Okay. A number less than 3. Zach, how about a number less than 3? Okay, 2 out of 6, all right? Because if it's less than 3, then we're just talking about the numbers 1 and 2. So that would be 1/3. All right, so answer these two on the check it out. Right. So there's theoretical probability, what you expect to happen. Now, if you got a deck of cards, all right, then things to remember about a deck of cards, you've got 4 suits. All right, there's ace through king in each one, so there's 13 of each kind, each diamond, heart, clubs, and spades. And so if you get questions that involve cards, then you remember that each of those are equally likely also. All right? The probability I would get a red card would be 1/2. The probability I might get a diamond would be 1/4, and so on. When you toss a coin, there are no possible outcomes, or there are 2 possible outcomes, heads or tails. The table below shows the theoretical probabilities and experimental results of tossing a coin 10 times. So they did it 10 times, they got 3 heads and 7 tails. Theoretical probability, we expect that half of them are going to be heads, half of them are going to be tails. Now, if we take and we add the probability of heads and probability of tails together, we get 1, okay, 100%. Or add the theoretical probability. Okay? So the sum of the probability of heads and the probability of tails is 100%. Because it's certain that either one or the other thing is going to happen. Right? So the probability of an event happening plus the probability of an event not happening is equal to 1. Right? And this is where we get what's called a complement. Right? A complement means the other thing. Right? So if the probability of a boy in this classroom is 5/12, then the probability of not getting a boy would be what? Okay. So if the probability of a boy is 5/12, the probability of not getting a boy is what the complement is. And so what we can do to find the complement is we know those 2 things have to add together and get 1. So if the probability of a boy is 5/12, the probability of a girl or not a boy then would be 7/12. Right? The 2 things together have to add up to 100%, or 1 when we're adding them together. So here a box contains only red, black, and white blocks. The probability of choosing a red block is 1/4. Probability of choosing a black block is 1/2. What is the probability of choosing a white block? Right. And so we know that these 3 things have to add up to 100%. So if I have 1/4 is red, 1/2 is black, then 1/4 is going to be white. Right? So the probability of white is equal to, and we can think of it this way as 1 minus 1/4 minus 1/2, which is equal to 1/4. Because we have all of them added together have to equal 1. And I take away the probabilities I know to get the probability of what's left. Right. So find this problem. All right. Okay, odds. They're another way to express the likelihood of an event. The odds in favor of an event describe the likelihood that the event will occur. The odds against an event describe the likelihood it will not occur. Right? So when do you hear about odds most of the time? Or do you ever? Something just happened recently where odds would be big. Right? What just happened recently where they would have a lot of odds? They'd talk about the odds. The election, that would be one thing they did. Okay, all right. Something actually, I was just thinking about the Super Bowl. That there's a lot of people who bet on who's going to win the Super Bowl, and I actually heard that some guy at halftime of the game, because he was so confident his Falcons were going to win, that he ended up losing them $5 million because of he was so confident. All right, but at that point in time, if you looked at the odds, because nobody had ever come from behind more than 10 points behind in a Super Bowl before. And so the odds of the Patriots doing that were, pretty slim. So, Now, odds are a little bit different than probability, okay? So when we talk about odds, we're comparing the favorable to the not favorable, okay? We're not comparing the favorable to the total, okay? When we do probability, it's favorable to the total. When we're talking about odds, we're talking about favorable to the not favorable, all right? So odds in favor, number of ways the event can happen, divided by the number of ways the event cannot happen, or can fail to happen. Odds against, all right, fail over the number of ways it can. All right, so in this case, A represents the number of ways it can occur, B represents the number of ways that it fails to occur. Right? So the two numbers, though, that you're going to be using for odds add up to the total. All right, so when we're doing probability, it's always in favor over the total. When we're talking about odds, it's in favor over to not favor, and those two numbers have to add up to the total then. All right, so the probability of rolling a 2 on a number cube is 1/6. What are the odds of rolling a 2? All right, so we listed these before. Let's list them again. Our sample space. All right. So the odds of getting, or the probability of getting a 2 is 1/6 because there's 1 out of a total of 6. All right. So if there's 1 2, how many things are not a 2? How many not 2s are there? Okay, there are 5. So the odds are 1, 2, 5. All right. Now odds can be written a couple different ways. We can write it as a fraction still, all right, or with odds, you can write it as with a semicolon, all right, 1 to 5. Or, yeah, that's a colon. That's not a semicolon. That's a colon. Okay. All right, so we've got 1 in favor, 5 not in favor. All right, so as a fraction, 1/5, or as using colon, 1 to 5. All right, so the odds in favor of winning the contest, excuse me, are 1 to 9. What is the probability of winning the contest? Right? And so the thing to remember is that when you're doing odds, those two are the total when I add them together. So in this case then, the probability that we win is 1, and the total then, I add those two together. So I'm going to add them together for my denominator, so it's 1/10. So there's a 1/10 chance of winning if the odds are 1 to 9. Okay, so you answer letter C. Okay, so with odds, once again, all right, remember that the two numbers together add up to the total. So when I change odds to probability, then like in this case, I have 2 plus 3 is 5. That's going to be my denominator. All right, and so you have to remember that when we're in odds, we add the two to get the total. Probability, the total is in the denominator. Now, one thing to remember too is we got this reading math part over here. It says you may see an outcome called favorable. This does not mean that the outcome is good or bad. A favorable outcome is the outcome you're looking for in an experiment. So it might be a negative thing that you're actually looking for that's your favorable outcome. All right, so you have to remember that sometimes that happens. Okay? All right, here's your homework.